All right, it is September 8th. I'm sorry about all of the shadow, but it is what it is. I want to thank you all for logging on and doing this science video. This is one of the first times I've done a science video. Most of the time it's all about reading. So this has been a little different for me, trying to get the prep and all of that done. So I'm going to try to make it as interactive as I can. If you are in the seats here at school, this unit is normally a lot of hands-on, and I'm not really sure how to do that with you guys not being here. So I'm going to try to find some YouTube videos, things like that, to kind of mix it up a little bit so it's not all just read and answer questions. But for some of it, that's the best that I know how to do. So if we were in here in class, it would be different. But this first particular lesson would be exactly the same. So we are starting, well, before I do that, you have an attachment that has this whole unit, has the pages on it. Not sure why it's kind of being delayed. So if you want to, you can scroll through the bottom and you will see page after page that has the textbook on it. Don't have enough textbooks to send home or give you the opportunity to take them home. I have what I consider a classroom set left, and we have to share them between Miss Frederick and myself. So this is kind of how we do it. I do have some runoff copies when we get ready to have a quiz or a test for kids who want to check those out to study. They are available. What I will tell you is you will be taking notes during this science lessons. Your notes are always pretty much what's going to be on the quiz and or the test. It's all the important pieces of information that I think you will need. Science is a little different from reading. It requires a little more analytical thought sometimes. So you do need to know vocabulary words. That's a given. They're going to be on Quizlet. You're going to have to practice those daily. But it's different in the way that it's not just that you know the words, but that you know how those words are then used in real life. What do they really mean? It's more than just a physical property can be seen or measured. What does that truly really mean? And I pulled that right off of here. Okay, guys, what does that really mean? And that goes with our end in mind for today. Just like reading, every day in science, there is an end in mind. Some of those end in minds will go over into 2 days. But our end in mind for today is I will use simple strategies to determine meaning and understanding of vocabulary for reading, including the usage of prefixes, suffixes, and root words, multiple meanings, antonyms, synonyms, and word relationships. It's a whole lot of verbiage there, which means that in today's lesson, we're going over vocabulary, exactly what does that mean, and so forth. So I'm going to slap this on my board back here. And there's another piece that I'm trying to pull off because I already had it hung up, is that in our science lessons, we have what I call an overarching question. That through this whole chapter 13, we will revisit and re-answer at different times because your answers will build upon each other. And as we learn new things, then your answer could change. So the big question is, how can the properties of matter change? And we're going to be talking about that really in depth when we get to Unit 2 of this chapter. But how can the properties of matter change? Let me slap that back up on the board. Okay, I think I got that. Now, so I want you to think about all the things that are in the room around you right now. Take a look, take a glance. And then I want you to think about outdoor space. And in your notebook, I would like you to think about all of those items and what are they? If in the classroom here, if I had to say what are things in the classroom that are taking up space, that's better. I would say, or if you were here, we would write them on the board. So I would say classroom. What's in here taking up space? If you're in your bedroom, your list may be a little different than what this one's about to be. We could say desk, take up space. I could say lockers. I could say people, because there's someone else in here with me today, so it's plural. We could say filing cabinets. What else? I could say tables, bookshelves. And how would, there's more things we could keep adding, but how would this list be different if we're outside? So we want to think about outside. Move our end in mind over. Let's get a different color. So what is taking up space out there? Okay, I'm looking out the window. We could say trees. I could say playground equipment. I could say grass. But so far we're listing only solids. So when we think about matter, it's solids, liquids, gas, and plasmas. So what are some liquids that take up space? Outside, we might say lakes. We might say ponds. We could say oceans. But how about gases? Both of these settings have a gas in it. Exactly. It would be air. Air takes up space and you don't realize it, but it's all around us. I couldn't find my balloons. Usually I will blow up a balloon to demonstrate how air takes up that space. Before I blow it up, that balloon is limp. There's nothing to it. But once I add the air from my lungs into that balloon, it just keeps expanding and expanding and expanding. And I can clip off the neck. And when I let go, kind of flies everywhere. And the air is let out. Where does the air go? It's still here. It just is taking up space within the walls of this room. So air is all around us. So when we think about how can the properties of matter change, they do change. They change depending on how heat is added, heat is taken away, they're changed, that changes their shape, it changes their from a solid to a liquid to a gas. And those are things that we're going to keep thinking about as we go through this particular lesson. So anything that takes up space is called matter. That's the first thing I want you to write in your journal, besides this list. And then I want you to star it, because that is a phenomenal quiz and or test question. So here I say it again. Anything that takes up space is called matter. Doesn't matter what it is. If it's taking up space, it's matter. Now, the next thing that we're going to talk about is we're going to talk about the vocabulary words that are on this page. And I know it's going to give this weird effect again, and I'll try to step out of the way. But I do want you to be looking at the words as I go through them. It does kind of add a little bit to it. So the first word we're going to talk about is a physical property. A physical property can be seen. And then it is, how would you describe it? Here they've given us copper, and then they've taken that copper and they've pounded it into wire. And then over here is copper in its rarest form. And when I say rare, I don't mean valuable, but it's in its most broken down state. It's how it begins before they start shaping it and selling it. So what I have here is a twist tie. Now, if I were to ask you, what is the physical property of this twist tie? I want you to think about that it is what can be seen. How would you describe it? You might say that it's white. All right, now it might be long. I can twist it. And now you might say it's in a circle. Okay. But you might say that it has a like waxy covering over it. But I took my scissors and I kind of took the waxy cover off. Now what I have, if I'm going to say what can be seen, I also have a silver metal material that kind of has a sharp point. These are the physical properties. It is exactly what you are looking at. How would you describe it? I would say that it's bendable or malleable, which means that it can take on multiple shapes depending on how you twist it, okay? So, physical property, it can be seen, and it's how you would describe it. Now, some of you might be taking notes, which would probably not be a bad idea, because all of the vocabulary words are going to end up on your test or a quiz in some way, form, or fashion. It may be just knowing the basic vocabulary word, but then it's going to turn into application of vocabulary. Do you really know what it means in real life kind of situations? Now, in your book or in the upload, you have this page, and it's going to tell you which pages to find the words on. If you'd rather wait and just kind of do it as you go, that's fine also. So this is physical property. Now, a chemical property, which is down here at the bottom. And down here at the bottom, it's hard to see what that is, but it is firewood that's been set on fire. Chemical property explains how something new is formed when another element is added. So, what the heck, Miss Kim? That's a whole lot of words. So what I want you to think about is that if I go out in the woods and I bring home a log, okay, I could describe the physical properties of a log, right? I could tell what it looks like. I could tell what color it is, how long it is, what the diameter of the log is. I could physically describe the log. Now, However, what happens to that log when I set it on fire? Something to think about. That's what we're talking about when we talk about chemical properties. When I add that other element, the other element is fire. Wood is flammable. So when I add fire to that wood, that is the chemical property. That is the end result. When that wood is burning and it's all the way burnt out, a whole new substance is created. The physical property is that it's flammable, okay? But something new is created by that, and it's ash. However, the chemical property is the new element that is added. And in this example, it is fire. Now, that takes us to a chemical change. Chemical change and chemical properties can be very, very similar, and kids always mix them up. And that takes us right here to these candles, okay? Now, a chemical change is where you turn into totally something new. There's no going back. Once it's changed, it's changed. You can't fix it. And so I want you to look here. I have a brand new candle, and the white piece of my candle is called a wick. It's a wick, and it's like a cotton fiber, and right now it's just what it is. However, when I add that new element of fire, we're taking this chemical property, and I'm going to show you now how that chemical change takes place. So when I add fire to the wick, and I'm going to let it burn just a second, because as it's burning, that cotton wick is flammable. And as it's burning the cotton, there's no way to go back to its original state. That cotton, as it's burning, now turns into an ash. When I blow it out, it's not going to have that same firmness to it anymore. There's no way that I can get the original color back, that I can get the original sturdiness back, because it is forever changed through a chemical change. Chemical change is where it turns into totally something new. Just like wood changes into ash, this cotton will change into ash. And it's not just when fire is added. A lot of times as we go through this unit, we'll talk about these changes. And is it turnaroundable? So I'm going to blow it out. You see that? Now, you see how it's just shriveling up. It just came off in my hands. That's the ash. See that? It's kind of a cool thing if you think about it. Every property on earth has a different chemical property to it. What is their kryptonite? If I add this new element, what happens? It's kind of a cool thing. So this one's going to the side. Now, we're going to talk about physical change. And I really tried to make this drippy looking wax. I've had this poor little candle burning now for an hour. The only thing that's happening is it's getting a whole lot shorter. A physical change is where no matter what you do to something, it's still the same. So I'm going to set that to the side because it doesn't have the same effect as these drippy kind of candles do. That if you collect that pool of wax, and I had a cousin that used to work at a candle factory. There used to be one in Corbin. It was called American Greetings. Some of your grandmothers or grandfathers may have actually worked there. And one of the things that you could do is you could buy items in like their little store. And he always had these great big giant pillar candles, like 5 or 6 burning at the same time in like a lunchroom tray. And what would happen is as they would melt, all of that wax would collect in the bottom. Now, it was changing shape. It was changing size. But the end result was all of that wax in the bottom was still wax. That it didn't really change. That's what a physical change is talking about. The look might change. However, the actual gut of the item doesn't change at all. Like hair. I have my hair colored. I was born a blonde. I was a blonde till I was probably about, I don't know, 12, 13. And as I got older, my hair started getting darker. I didn't like it. So I go to the beauty shop and they do a treatment on my hair. Okay. They change up they put chemicals on it to give it a physical change. Now, is it still hair? Yep. I could go tomorrow and say, I want red hair. They could put some red chemicals on it. I've got red hair. It's still hair. It's just looking different. Now, the next one we want to talk about is weight. Weight is just the measure of gravity on an item. And on our thing here, we have a spring scale. And we will be using spring scales. Or we would have been using spring scales in class to do some hands-on activities, and we actually will build some spring scales. But one of the things I want you to see is that if I pull on it a whole lot, what happens to the spring? It stretches. And it's because I'm adding more weight to the hook at the bottom, and that affects the gravity within inside the tube. Now, if I pull it just a little bit, it just moves a little bit. Okay, weight depends on gravity. Now, we've all stepped on a scale before, and some of us more than others as we try to maintain our weight. But when we get on a scale, there are mechanisms inside that are really determining how much gravity your body is pulling, and that determines your weight. So when I step on that scale, it's not as much as, oh gosh, I've gained such and 5 extra pounds. It really should be, oh man, I've added 5 more pieces of gravity to my body, which means that now I'm taking more to hold down onto the earth. So when we think about gravity, it's just about, or weight, or gravity, it's about, or weight is how much gravity. Get my words twisted up. Now, here's a good one. Density and volume. And then we're going to call it quit. Let me walk over here real quick. Now, density is the measure of the amount of matter in a given space. And so I have a beaker, and in the beaker we've got all of these little measurements up the side. These are milliliters. And then I've got this real wispy kind of floral grass that you buy in big giant bags at Walmart or the Dollar Tree. And I'm going to stuff it in my beaker. Okay. And when I stuff it in my beaker, I've got like 150 milliliters of this stuff. Okay. Now, we've got to keep in mind that density is the measure of the amount of matter in a given space. Okay. 150. Now I'm going to take that out. And then I have these fish rocks. And with the fish rocks, I'm going to put 150 milliliters of fish rock. Okay? And they are actually rocks. So when we think about density, it is the measure of the amount of matter. Now, one of these feels heavier than the other. And it's the rock. If I were to weigh the rock has a higher amount of gravity that's pulling them. So they are heavier. Now, do they take up the same amount of space? Yes. However, one of them has a greater weight than the other. Now, put that back in there. Shoo, that little grass goes everywhere. Put that here. And the last thing we want to talk about is volume. Volume is one that I usually like to talk about, and we'll talk about it a little more as we get it in the actual textbook. Volume is the amount of space that something takes up. Now, let's say you have, I don't know, a 12-ounce can of pop, and you pour that whole can of pop in a glass. The whole thing. You don't sneak a sip. You're just opening it and you pour it. How many ounces went into the glass? 12 ounces. It didn't change just because the shape of the container changed. So when we think about volume, it is about the amount of space that something is taking. So there's our vocabulary review for today. I want you to keep in mind that these science lessons will change a little bit as far as length. So today I'm going to have you log into Quizlet so that you can start playing around with the vocabulary words. I'd like you to do that for at least 10 minutes. You've already done it for reading, or you might have done science first, I don't know. Every day, though, you'll do 10 minutes of Quizlet for reading and 10 minutes of Quizlet for science. So that should just be part of your day. Keep in mind that I have the teacher side of Quizlet. I know which of you are doing your Quizlet every day. There is a Quizlet test at the end that I will be using as a science score. So you want to make sure that you're doing it, guys. All right, that's all I got for today. Catch you on the flip. Bye.